Welcome everyone. Our speaker is David Anderson. He's been in the IT industry for about 20 years, most of that as a production support DBA for Oracle, SQL Server, and Red Brick implementations. He moved over to the solution architect side of the house about 7 years ago, with Oracle finally landing at MemSQL at the beginning of 2018. Please join me in welcoming David.
Hey everyone, I'm not going to use a mic unless anybody really can't hear me, because I prefer to just talk loud, if that's okay. Can you guys hear me in the back? Cool, very cool. So yeah, we're going to talk a little bit about MemSQL and Kafka today, and how some of these technologies are being utilized to really power real-time applications. Before I really get into that, though, I wanted to share a story that recently happened with me. I was just doing my everyday job, and like every other company out there, we use Slack, and somebody slacked an article with a link to an article that said something along the lines of data is the new oil, which is kind of cheesy, but it really resonated with me. I think part of that is because I'd recently rewatched that series, The Men Who Built America. I don't know if you've seen that. I highly recommend it. It's very interesting. And there's a lot of corollaries in there between the whole episodes with Rockefeller and that statement, and it really kind of made me think, because I don't know if you don't know the whole story with Rockefeller, but basically he recognized the coming wave of importance of oil, and he spent a lot of time and money in implementing architectures to move oil around, to refine it, to make it available for people, so it's easily consumable. And if you look at the way companies are going nowadays, the big boys, the ones that are really pumping out a lot of products or making a lot of money, what are they doing? They're utilizing data to either sell more of their products, or they're actually just monetizing data. Your Googles, your Facebooks, your Amazons. What are they really dealing with? Mostly data. And the faster you can get that to a decision-making process or to your consumers, the better off you are. So just kind of keep that in mind. That's kind of an important thought process for me. As why is data important? It's because it's behind everything nowadays. So we're still fighting the same problems today that we've been fighting for the past 20 years when it comes to IT and data in general. And those problems are everything is too slow. The time it takes for a query to come back for your application or for your user is just, it's too long. Your reports, it takes you hours to actually generate a report, and when you get that report, it's based on data that was obtained at the beginning of the report. Not very useful. And like I said, we've been fighting these problems for 20 years. You can't do a lot of concurrent user access to your system because it just dies. And everybody's run into this one, I'm sure. You've got a daily report that needs to be out at the end of the day, but it takes 27 hours to run. We've all been there. We've all seen it happen a million times. These are all very common things, and again, we've been fighting these same problems forever. Possible approaches, things that we've been doing to try to fix them. I called this basically rolling out the money catapults. You've got a poor performing query, you can tune the query, try to make it better, but you eventually get to a point where you're going to throw money at the problem. You're going to add appliances, you're going to add more CPU, you're going to add more memory, or you're going to use expensive database options. Speaking of which, how many of you have been burned by somebody went in and clicked on the button to make the query go faster, and then you get audited a few months later? Whoops, so now we owe you $9,600 for every CPU core because somebody clicked a button to make that query go faster. Whoops. You can add caching tiers. There's a lot of those out there, and they do help, but there's problems with data durability. One of my customers lost a whole week's worth of data when a Fusion IO bank went down and they didn't have proper backups. Issues. Weak SQL coverage, obviously, you can't always interact with those caching tiers the same way you can with just a straight database, and it is another layer to manage. It's complex. You can try NoSQL. Sometimes it works, a lot of times it doesn't. Not always very performant unless you've got really good developers. And they're very a lot of work to get to the point where they are responsive, and a lot of times they just don't play nicely with BI tools. There's not a really good NoSQL interface to some of those guys. But I mean, there are times where it does work. So nowadays, new data architecture, Kafka is a big player in this realm. There are other tools for streaming type implementations. You know, Spark is out there, Flink is new. But Kafka has been a really big player that we run into quite often. We actually really like it when we come across a company that is utilizing Kafka for their messaging, right? Because that's what it is. It's a messaging queue. It's distributed. It's durable. It's very simple to use because it's just a simple either publisher or subscriber. It's a source of truth. It's free. It's open source. It's great. You can scale it as wide as you need it to be, and it's just very easy to use. And just out of curiosity, how many people in here are actually familiar with Kafka at all? Awesome. Yeah. See, it's been around. Everybody's using it. Everybody loves it. It's great. And then there's MemSQL. Obviously I work in MemSQL, so I'm a little bit biased here. But MemSQL offers extreme performance at scale. We're what Gartner has classified. Was it Gartner that came up with that term? I don't know. Somebody came up with the term NewSQL, which is essentially NoSQL scale, but with ANSI SQL support. So you can still use all the familiar SQL language that you've used for years, but you get the scale of NoSQL. Very easy to use. Cloud native. We basically just need a 64-bit Linux kernel. We are supported on all the major cloud vendors, AWS, GCP, Azure. We have a marketplace offering and a CloudFormation template for AWS, but simple deploy. On-prem as well, doesn't really matter. And OLAP or OLTP workloads. And that's kind of a big statement because it's usually in database world, you're either one or the other. You're either an OLTP system or you're an analytical system. You'll see in the center of this diagram here, that's really kind of the heart of MemSQL, and this is the reason we can support both those workloads, because we have memory optimized tables. That's our row store table. That's 100% in memory. Data, indexes, metadata, everything is in memory. It is persisted to disk though, so you don't have to worry about that. But we also have disk-based column store tables, and that's where we do our analytical type workloads. So we can do both in the same instance, freely join between either one of the tables. It's really, really good for analytical workloads. But we also support streaming ingest. We have native connectors for Kafka, obviously, Spark, Flink, Informatica, Talend, Illuma. If you're doing any CDC, we work with Attunity. We actually have some implementations. People are using IBM's FlexRep, also Golden Gate, to migrate workloads from DB2 or Oracle. We do a lot of Oracle displacement. We have our own CDC tool that we provide at no charge for Oracle implementation specifically. But we connect to basically anything that can talk to MySQL, talks to MemSQL, because we utilize the MySQL wire protocol. We actually utilize either the MariaDB client or the MySQL client for connectivity. So if there's a tool out there that doesn't explicitly state it can talk to MemSQL, but it talks to MySQL, chances are it's going to work. But we do have native connectivity into things like Tableau, Looker, Zoom Data, MicroStrategy. We can pull directly from HDFS, Azure, S3, NFS. So, and that all ties into pipelines, which we're going to talk about in a little bit, which is when we're going to get into actual streaming type of data. And I'm going to show you guys exactly what we can do with a Kafka pipeline into a real-time smart meter application. That's what we're going to show. And by the way, you guys stop me at any time. I know I talk really fast, but if anybody has a question or a statement, just wave your hands at me. I love being interactive, so please feel free. So underneath the hood, MemSQL is just a Linux daemon. It's a binary. Again, we just need any 64-bit Linux kernel, Red Hat, CentOS, Debian, Ubuntu, doesn't matter. We distribute it across all the multiple different nodes, so any multiple different EC2 instances or whatnot, and there's really only two flavors. It's either going to be an aggregator node or a leaf node. Aggregators are what clients connect to. Leaf nodes are where we store data in partitions, which are actually standalone single MemSQL databases that are shared nothing. The only thing that those databases know is that every once in a while somebody from the aggregator will log in and ask for some data. So when you create a database through an aggregator, what we actually do is create any number of underlying those single instance MemSQL databases underneath the hood. So if you create a database foo, we're actually going to go log onto those different leaf nodes and create 10, 12, 20, 1,000 other partitions of an iteration of foo. So from a user perspective, though, it's a logical database foo. Now, when you interact with the database, so say you do a select average price from an orders table, what's happening underneath the hood is that aggregator is going logging into the leaf, logging into every one of those underlying partitions, doing a sum and a count. So it's harnessing the power of all that compute, all that memory, and then pulling it up to the aggregator. The aggregator combines the results, spits it back out to the client. So it's MPP execution across the entire cluster. Extremely powerful. We can scale up and down on the fly, so you add additional leaf nodes or aggregators. It's an online operation, and you can just rebalance the data across those on the fly online. Okay. So pipelines. This is how we're getting data into us, and this is how we really start doing real-time activities. So it's a built-in create pipeline function. I'll walk you through the syntax in a little bit, but it does provide transactional consistency, exactly want semantics, and again, we can pipe into NFS, Spark, HDFS, blobs, S3, Kafka, and pull data in as soon as it lands. So when it comes to Kafka, we actually store the Kafka offset in a table, and then we distribute that across all the different leaf nodes. So we co-locate the Kafka offset with the data. So it's just extremely efficient, and we can take advantage of all however wide your Kafka cluster is, we can connect all those brokers directly to MemSQL nodes as well. So in any of these cases, be it HDFS, Kafka, Azure, whatever, we will just sit there and pull the source. We'll look for a file to come in. We'll look for data to land on there. And as soon as it does, we pull it into memory without a commit. So if you want to do some transformations at that point, you can do that. So call an external Python library or an R script or a C script, an executable, whatever you want to do any of your data massaging as data comes in. So let's move away from the whole concept of taking data, putting in a database, doing a process to put it in the format that you want, and then come back in and do your reports. Get your source data. As the data comes into the system, put it in the format that you want it to be in. Don't take another scheduled process to run after the fact that could take time to do it. Put the data in the database in the format you want it in to begin with. So once we have it in memory, if you've applied a transform or not, we will commit it in a transaction and in parallel across all those different leaf nodes. Now you can do that directly into the table, or you can actually go into a stored procedure. So we have our own extensibility language, very similar to PLSQL. But if you want to do your transformation in that space, you can do inside of a transaction in our extensibility language. So again, back to Kafka. When you build a Kafka pipeline and you go out and you say, okay, I want to subscribe to this, I want to talk to this Kafka broker and subscribe to this topic. That first broker will connect into the aggregator, we'll query it, we'll find out information, the metadata about all the other Kafka brokers in your Kafka cluster. And then we will marry those different Kafka brokers to different leaves in the MemSQL cluster. So now we've basically taken two distributed systems and we've got them talking together at once. We will pull data into those leaves from those topics as they come in. And now if data lands on a leaf where it doesn't actually belong, if it needs to be on another one, we'll just do a reshuffle on the back end. But we're churning in that data from Kafka as fast as they can send it to us. And that's how easy it is to create a pipeline for Kafka. Very, very simple syntax. If you've got one out there, like this is a public Kafka topic that we utilize in demos all the time. It's tweets. You can connect to any of these and just start streaming that data in, put it into a table right away, do transformations if you want, and then start querying against it. What's pretty fun with the Twitter data when we do that example, we also enable full text search. So you could put a full text search on this table, on whatever column you're looking for, and start doing interesting analytics on particular types of Twitter data, be it So we supply a full Lucene search engine, so you can do fuzzy searches, whatever you want to do. So really interesting things, especially with things like Twitter. But I'm going to go ahead and jump into a demo now. So I've got some data running. Let's stand by. Okay. So this is just a dashboard for MemSQL. You can see I'm pulling about, it varies anywhere from a couple 100,000 to 1 million rows a second into this. This is a very small MemSQL cluster. This is one aggregator, one leaf. So this is the smallest you could get with a MemSQL cluster, but I'm still able to pull in about 1 million rows a second in some cases, usually around 300,000. And it's 2 nodes, hardly doing anything there. But the pipelines that we've got running, and this is all simulating a smart meter data. So, you know, that's a big thing nowadays. All of the major power providers are moving to smart meter data. They got trucks that drive around, pick it up. But everybody wants to know, how much energy am I using? How much energy did I use yesterday? How much did I use for a month or the year? There's all kinds of analysis being done on that. The power companies are using that to try to troubleshoot problems before they come up. So, like, you know, is there a problem with this particular line? We got hot transformers or anything along those. So again, this is the power of data that we're utilizing a lot of this. The problem is there's a ton of data. There's so many different meters out there, and they're constantly sending information in. So what I've got going on is this is a Kafka. We're subscribed to this Kafka topic AMI reads. We're pulling in data. It's in a CSV format in Kafka. We're actually loading this into a procedure called data validation, and I can show you exactly what that's doing. But essentially all it's doing is pulling in a meter read and doing an analysis to say, okay, is this higher than normal utilization or lower than normal utilization, or is it within the realm of average utilization? And if it goes outside of that, it raises an alarm and pumps that data into a different table, an alarm table, which we'll see how an application will actually utilize that in just a moment. But yeah, we're processing a lot of data here. You know, we did 140,000 in 381 milliseconds, 140,000 in 180 milliseconds, but just this Kafka topic is constantly spewing out data. And that's the beauty of Kafka. It just keeps going. And if a lot of you are familiar with Kafka, you know that, oh, you know what? We had a problem. We need to go back to a particular offset. You can absolutely do that. You can start up a pipeline and say, start with that offset. So as long as you keep data in the Kafka cluster in the logs and you have that available, you can start a pipeline and go back to that and start playing from that point forward. Or you can just go to the current offset or one in between. So what Kafka is beautiful. We've got another one. This one isn't doing as much, but same type of thing. It's going into a transformer reads stored procedure, and in this one what we're actually doing is we're looking for high or low voltages. So we're trying to determine the health of the network to see if a transformer is going to blow up, you know, which I'm sure PG&E is really interested in trying to find out. Yeah, oopsie doodle. And the last one is just pulling in voltage reads. This one's not going into oh, this one is going to a voltage validation one. I thought I had one that was just going straight into a table. That's okay. Either way. So what can we do with this? You know, now we've got all this data streaming into this database. Let's put a dashboard on it. Right? I mean, this is a Zoom data dashboard. This is updating, I think, once every second. We can refresh it manually. But you could see, you know, we're just tracking things like, okay, this particular meter has a lot of high read alarms, and you know, just kind of giving us the higher volumes that are coming through here. We've got another breakdown over here, total low read alarms, and I don't know if I'm not really a BI guy, but this tool's pretty simple. Anybody out here familiar with Zoom data? Anybody using it? Yeah, everybody's using Tableau. Yeah, yeah, that's fine. Just somebody else had built this simple dashboard, and I was like, okay, instead of me building a new dashboard, I'm going to use this. But we can do some interesting things here with it. I can trend data, and it'll build a little graph here. You can see different trends. And this is what everybody's trying to get to nowadays. They don't want to do a report and see what happened yesterday. They want to see what's happening right now. In order to do that, you need to have the architecture in play to do that. You need a real-time database. You need a real-time feeding that database, and you need something to be able to visualize the data or spit out queries. So this is just one dashboard here. This is not actually the more interesting one. I want to show you the one that I really like. So this is cool. This is data back to 2017, and this is refreshing. I don't know what this did, but we can refresh it manually here, and boom, just constantly pulling in this data. And I mean, you can see points from usage. These are total sums of utilization over the entire time frame that we have in here. And this is just constantly being fed, constantly updating with new data as we go. Getting high and low alarms, data aggregations, total utilization. But really, this is what we're aiming to get at. And this is what things like Kafka and MemSQL enable you to do. Now, before I go on, I mean, does anybody have any questions, comments? Are you seeing the same type of things in the industries you're in? What's that? How do you charge for it? No, well, Kafka is open source. MemSQL is a commercial product. Yeah, so yeah, MemSQL we don't charge for ingestion or anything like that. We're a subscription-based database service. We're software, but you can deploy us, like I said, in AWS, GCP, Azure, or on-prem. And really the way we deploy, we like pizza boxes. You know, so 1U, 2-socket machines. Commodity hardware, any flavor, as long as it supports 64-bit Linux kernel. Put it on Ubuntu, put it on CentOS. Red Hat is typically what people use for on-prem. And then it's just, we charge by a node. And our definition of a node is either 8 cores or 32 gig of RAM, whichever is bigger. But you can go out right now and download MemSQL for free, put it in production. The only limitation is you can't go more than 4 nodes, but that's 128 gig of in-memory and endless amounts of disk. So a lot of people are using us for that. There's a company called AnyVision that utilizes us for facial recognition software, because we do a lot with that. Actually, if familiar with Thorn is a nonprofit that does sexual predator detection. They look for sexual trafficking of children via facial recognition, and we're the back end for that. But yeah, just go download it, put it on 4 nodes. It's free to use as much as you want. You won't get any support, but there's a very healthy forum and community that are out there helping them. And actually, our engineers are constantly answering questions on the forum as well. But I mean, we're doing this type of work in all kinds of different places. 5 of the top 10 banks. We're in a lot of high tech, so Uber, Pandora, Hulu, Akamai, and in the banking space, American Express, Goldman Sachs, PwC, all just you name it, we're probably in there. Just you got to get to a point. Oh, I'm sorry. Go ahead. No. I'll keep talking forever. It's a little bit of both. It's mostly though, so if you need to go back and start replaying a pipeline from a specific offset, you can do it. But we track the offset with the data that's going in, so we can ensure consistency, and we know we're at the right point in time, and that's just from a performance perspective. Sure. Yeah.
Only once. Yeah. You don't want duplicate records in there. The same record being read twice in the database.
But you also want to make sure that you got it. So that's exactly when semantics are what you're looking for. Yeah. You bet.
So, is this going against that analytical store or the transactional? Touched on that a little bit.
Oh no, this is going against Columnstore. So so almost every smart meter implementation that we do is against a columnar format because the data quantity is just so much. And in the way that we segment the data, we find that when you're doing analytical type workloads, our Columnstore is typically way faster than an in-memory row store, even though it's backed by SSD. But think of it, so it's in a columnar format, which is already very kind of leans itself to the analytical format, because if you're only pulling certain columns out of that, you don't have to scan all those other ones. But now we've segmented them up into smaller chunks of data, so like call it 1 million rows per segment, so 1 million entries for a row per column, and then distributed across the cluster. So every partition has its own collection of segments. So if you're looking, so say you're looking for one particular, in this case, smart meter. You're looking for one entry from a smart meter for yesterday. You want to find out what was my peak utilization for yesterday for this smart meter. You could have 500 billion, a trillion, 2 trillion rows in the table. Doesn't matter. If you've distributed that data on the smart meter ID, and you query that data, and you said, I need that's data from this smart meter for this date, that query is going to come back in a millisecond because we don't have to scan all those other trillions of rows. We know, okay, I want this data from this column, and the aggregator knows that, okay, it lives on that partition right there, and it's in that segment. So nothing else matters. Just go right to it and return your values, and you're done.
But this particular demo has actually both Columnstore and in-memory row store.
Mm-hmm.
So the previous chart with data showing about the can you show the chart?
Yep. Alarm
The
reads.
alarms over here, right? So there's a high alarm and a low alarm, right? So those values are actually kept in memory, and the reason for that is there's a store procedure. This incoming data, right? So you have about 200,000 or 500,000 records that's coming, and in real time you are putting those values to a stored graph that's actually checking against a table to see if it's crossing the threshold, right? So that table is actually in memory. So because we have both in-memory row store as well as a column store, you can get best of both worlds. The data is streaming into Columnstore, but in real time we are checking against some values, that's the high threshold and the low threshold in real time. So that's why you're able to both check as well as put the alarms at the same time.
All this historical data is 100% in Columnstore.
So you have a transactional application.
Mm-hmm.
Needs the in-memory store.
Yep.
And then you want to copy the data into the columnar store.
Mm-hmm.
So how does that architecture work?
So from a user perspective, it's basically transparent if it's a row store or column store. It's basic. You're just writing a query against a table. If you want to actually move data from a row store to a column store format, we actually have plenty of procedures out there to take that data and to migrate in there. And a good example of that is GoGuardian. They're in LA. I don't know if you guys are familiar with GoGuardian. They're one of my favorite customers because those guys are awesome. They're really, really smart and they're super fun. And they do really interesting work with schools. So their GoGuardian is basically used as on the Chromebooks. You know, all kids nowadays, they all get Chromebooks. Well, the teachers, the operating system on there is run by the teachers, and they're constantly tracking everything that the students are doing. They can see what they're doing. They can tell them to go to a specific web page. They can see if they're on the web page. But it's also doing things like it's using machine learning to try to determine if there's potential self-harm, if there's bullying, if they're going to improper websites or trying to get to improper websites or things along those lines. That's actually also utilized in prisons for the same reasons. But they're taking data. So every click that a student does, every read that they're doing, it's very volatile data. So they're keeping all of that data for about 3 hours in an in-memory row store. Then they have a procedure. After that point in time, they flush it down to a columnar table for analysis to do all the machine learning algorithms against it to try to determine if there's potential self-harm and whatnot. So it's a common use case. We're actually moving towards what we call single store. We're not quite there yet, but and probably this time next year, you won't have to migrate data yourself at all because we'll do it on the back end for you. So as data cools off, we'll move it to Columnstore, but it's not there yet. So I typically don't like to talk about futures. Yep. Yeah. Well, really, what it'll do is when you put data in, if it's volatile data that's changing a lot, it'll just reside in a in-memory row store. But as it quits being updated, there's some algorithms in play that'll move it down to a column store on the back end. But from a user perspective, it'll just be one single table. And a lot of times what people do when they're doing things like that with like GoGuardian, where you have in-memory row store and then you have your historical data, but you still want to be able to query across both of them, you just create a view over the top and you do a union. So then your users hit the view, they get the historical data and the active data at the same time. I saw a bunch of hands earlier. Who else has got a question? Shoot. So we have native connectors to a lot of them, but basically, if there's a method or a way for them to connect via MySQL, because we use the MySQL wire protocol, so if it can connect over JDBC, ODBC via MySQL, then you can talk to us. Because it's actually pretty interesting. We have some proprietary structures. Obviously, we have a columnar format which MySQL doesn't have, and we have our own optimizers. We actually have two optimizers, one for an aggregator, one for leaves. There's a whole lot of differences there, but we're ANSI SQL compliant. So you can take a table in MemSQL, regardless of what it is, column store, row store, and you could extract the DDL from there and run that same exact statement into a MySQL database and it'd run. Because what we do is we hide our proprietary things inside of comments. So our engine recognizes a comment and knows what to do with it, but a MySQL engine will just say, oh, it's a comment, I don't care, and it'll run over it. It's pretty elegant. Go.
So when you have streaming data like this coming in,
Yep.
depending on the kind of data, the challenge that often comes up with it is you start to run into a point where the queries and analytics that you won't want to run into start to just get too complex to do on top of the raw data. And you start having to build views or tables or a processing pipeline or everything else in multiple steps, and each of them take. So you start, and that's unavoidable inherently kind of in the SQL.
Yes and no.
I mean, you can do views on top of it, right? So
Mm-hmm.
I'm interested, like, if it isn't what sounds like you have a solution to that. So I'm curious, like, how that would look without essentially just you constantly rerunning.
Yeah, so
calculations.
from our perspective, don't store multiple copies of your data. Keep your raw data and do your aggregations on the fly. Because when you have a system that's able to eliminate all of those different IOs that you would normally need to do in the columnar format, because I mean that's what you're talking about. That's the kind of data that you're talking about. All that raw data is going to go into a columnar format. So don't have processes that run every day that take, okay, I need to figure out what this data is for last week, and I need to build a new table and then have that an application hit that table instead of the raw data. No, build your application to do your aggregations on the fly against that raw data. And because of the way that we can eliminate the IO, the unnecessary scans of data, the performance is still just as fantastic if there's 1 trillion rows or if there's 5.
Okay, so we had a customer called Malwarebytes who was, they were on Postgres, went to Redshift, then Snowflake and FineGIPS. They had the same problem as you were describing, which is aggregation. So they had to do a lot of pre-aggregation. The reason why they were aggregating is they could support the queries per second. Right? Coming to MemSQL, what they did was directly run data queries against the raw data. The queries were longer, but they didn't have to do any pre-aggregation. And they were still able to get more than 1,000 queries per second against this base Columnstore. So no need pre-aggregation, running queries as is.
I just needed to double check on my cluster because this isn't a very large cluster and I'm streaming a pretty decent amount of data into it and I didn't want to fill it up. But 8 minutes, okay. Go. Yes, we are ACID compliant, and the way we do that is through MVCC. So we call ourselves the lock-free database, and I don't know how many of you guys are really database savvy, but in Oracle, there's a problem called latch contention and buffer busy waits. And a lot of this has to go around with the way that they introduce locks to ensure data consistency and whatnot, but it also has to do with B-tree indexes. We don't utilize B-tree indexes. We utilize skip list indexes, which are memory optimized and extremely fast. So instead of having to build out new leaves for indexes and take locks while you're doing that, skip list index is essentially just towers. You either grow a tower or you add a new tower, and that's how you're able to quickly scan an index and get to the point that you need. But where was I going with that? So yeah, lock free, yeah, MVCC. So we never ever block reads. Reads are never blocked. And what will happen is when a session comes in and you do a query, we will give you the most recent version of that query that was committed, or that block that was committed. And that's always the way it's going to work. So if your session started and you're reading an old version of a block, or at that point it was a current version of the block, if a new block comes in, well, new sessions will go against that new block, but you'll finish yours. And eventually, as that block is no longer being accessed, garbage collection will come in and pick it up. So you get a consistent view of the data at the time that you issue your query. The only time we ever block anything is when or lock anything is when a block is being written and another session tries to come in and write a new version of that block. So that session that's coming in will wait. So we'll commit the first version of the block, and then we'll allow the new version of the block to come in. So you're always going to get a consistent view of the data through MVCC. So yeah, ACID compliant for sure. Any other questions? I don't really think I had a whole lot more from a slide perspective. I think there was really, yeah, just a couple, why Kafka MemSQL. Again, we're enabling this live loading, fast queries. We're solving those problems you saw at the beginning. We're solving the problems that we've been fighting for 20 years, where reports are slow and they're done with old data, and your queries are unresponsive, and you can't scale because concurrency from a user perspective just doesn't work. Those are the problems that we're solving. Kafka is a big part of that, but essentially anything that you can do to stream your data in real time, we try to enable you to access it in real time as well. Yeah, lock free. We already talked about a lot of that, but yeah, give us a note, or drop us a note if you want to. Team@memsql.com. If anybody wants to talk to me, I can give you a card. Again, go download it, play with it. You can have it. Oh.
Any guidance on sizing? What kind of compression would you expect?
Yep, we get anywhere from, we always say about a 5x compression for the Columnstore data, but it really depends on your data type and repeating values. I mean, I've seen as high as 70x. Yeah, I mean, but that's like very repeated values in small, integers. 5x, I feel real safe saying. Yeah. And we actually do offer row store compression now as well for sparse tables. So if you have a lot of null values or zeros or whatnot, you can apply that to the in-memory row store and get better TCO. So yeah, right on.
In case where your nodes are down or something like that, do you have any?
Yep, built-in HA. Yep, it's a master-slave relationship. So if your master goes down, the slave takes over the workload. When you bring that node back online, the engine will recognize that it's back online, bring it back into the cluster, replay any transactions that have occurred back to the master, and then promote it back to master. All automatic. There's replication. You can replicate between data centers. That's offered at no additional charge. We're not Oracle. So yeah, everything. We don't have additional features really. We have a CDC tool to get you from Oracle to us that we'll give you for free. We're not trying to nickel and dime you. There are no database packs for us.
Did you just say there's a data center?
Absolutely. Yep. It's non-blocking. It's done at the block level. Very performant, and it's read-only on the other side, but you can do reporting off of it. So if you had a data center here, data center there, or even sitting right next to it, you could replicate a database over to that, do your reporting off of it. If this goes down, promote it, read write, away you go.
Do you have any benchmark? How long does it take to replicate from one to the next?
It's very fast. It really depends on the amount of data, but it's like, again, it's non-blocking and it's done at the block level on a partition basis. So essentially all we're doing is we're copying partitions initially, and then as changes fly, we apply the transactions at the partition level. Yeah, it's line speed, exactly. It's continuous. Yep. Yes?
How do you guys differentiate from the physical streaming?
From the what?
Kafka SQL, yeah.
Oh.
Kafka also provides SQL. I don't think they're yet calling themselves a database, but you find all these other, Spark is now calling themselves a database. Redis is a caching database. Kafka is still not calling themselves a database. It's for running SQL against streaming data, but at the end of the day, there's no historical
Yeah,
data.
there's no persistence.
Data is persisted only for the time period you mentioned where it be done. So you can run some queries against it. I don't think it's fully ACID compliant. There's a lot of SQL queries you can't run. Joins between tables, but now, like what you do in normal SQL, I don't think all that can be done.
Yeah, it's not ANSI.
Right.
It's not ANSI SQL.
Yeah. Well, cool. I think we're done.